Hi folks, I'm Vagni. I've been programming in JavaScript for a while now, and I've built several single-page apps with libraries like jQuery, SammyJS, Backbone, Angular, and frameworks like Ember. After having worked with Clojure and ClojureScript, I'm convinced that it solves many problems usually associated with large JavaScript code bases like code organization, performance, and modularization. The goal of this talk is to introduce ClojureScript, the language. We will cover basic tools like line engine and lighttable. We will have a quick whirlwind tour of libraries like code.async and code.match as well. I mean, they show the awesomeness of ClojureScript. We will explore the language, the tools, and libraries by building a small thing called the Conway's Game of Life. Conway's Game of Life is a cellular automaton devised by the British mathematician John Conway. Most people know it from the hacker symbol, or more popularly, as the term glider. So here is a short preview of what you can expect from my talk. We just saw how easy it was to find out neighbors for a given cell. So we are now going to have a look at the next state method. The next state method determines if a cell will live or die for the next generation. There are four rules to determine this. The first being any live cell with less than two neighbors dies. Any live cell with two or three neighbors lives on. Any live cell with more than three neighbors dies because of overpopulation. And finally, any dead cell with exactly three neighbors comes to life. The rules are quite simple, right? As we saw earlier. We would like to use pattern matching to solve this problem, but Clojure or ClojureScript does not support it. But the thing with ClojureScript that it is a Lisp and it has first-class support for macros. So a guy called David Nolan, whose name you will hear, quite a lot of times working with ClojureScript, wrote this really nifty library called code.match, which adds pattern matching to Clojure and ClojureScript. So now we simply have to find out the cell's neighbors, find out which ones are alive, and the population state of the neighborhood if it's overcrowded or underpopulated. We can simply match on those values now and get to the next state. So this, my friends, is what I call beautiful code. Now that we know how we can find the next state of a given cell, we'll see how we can evolve the entire board. So I hope that piqued your interest. If you'd like to see me talk about this, come catch me at JSFoo. Thanks.